Let's take a little look at the code and how we implemented a lot of those features. So this one's quite a big one, bit of a headache if you tackle it all by yourself. It's because the code base has changed so much, so many techniques have been introduced, and the lecture didn't really cover a lot of that stuff. So this one's a little difficult, but mainly to get your head around the code and the logic and the way the architecture has been done. So this is the pot update. So the requirements are: implement hearts that sometimes drop from enemies at random, which heal the player for a full heart when picked up. Also add pots to the game world from the tile sheet at random that the player can pick up, which will point their animation to change to reflect them carrying a pot when you carry the pot. And also when carrying the pot, you can throw it as a projectile and it should explode on a wall or an enemy, and then deal damage to the enemy, which may kill the enemy. So they're all the requirements, so let's take a look. The first one is implementing hearts. So for this, I go to entity.lua, which is here, and in here I added entity heal. So we already have a damaged one. When code is provided, I like to follow the architecture they use. I thought there was a better way of doing some of this stuff, but you don't really want two different ways of doing things in one project. It just kind of gets a bit weird. So I followed the kind of design for damage. I've just done heal. So each heart counter is half a heart, so if you pass in say 2 here, it will increase it 1 full heart, because each half heart is 1. So I just say if self.health plus the health we're about to have is more than 6, then set it to 6. That means our heart container won't overflow because it's a maximum of 6. We can expand on the game when we have larger heart counters and change these, and probably put these in the constants LUA. So that's just some optional stuff. If it's not going to max out, then just increase it by the value we want to increase it by. Very simple, really. And also in entity, I've added has reward. So when an entity dies, it's dead, I do a math random for 3, so 1 in 3 chance. If that is true, then the entity has a reward. So that's just a flag I'm setting here, and I've defined it up here. In GameObjects.lua, let's just find, there it is. So GameObjects.lua, we already have a switch. I'm just adding a heart now. So the type is heart. I think I added a type because I wanted to distinguish between objects in the room. So in objects we have switches, hearts, and later pots. I want to distinguish what an object is, so I've added this kind of type property here. So we can loop through all the objects in a room and work out if they're a type of heart or if they're a pot. It's useful when we look at pots in a few minutes. And in room.lua, I believe it's the update function right here. So we're looping through every entity, so they're the enemies and the player because they're all entities. If the health is 0, so that's this kind of logic here, we're killing the entity. This is where the code comes into play. So I'm saying if the entity has a reward, because we set that flag in the entity, then define a new game object called heart right here. It takes the defs in from our game objects definition here. And we want to spawn the heart exactly where the enemy was, so that's the entity x and y axis. We want to insert it into our self.object, so these are all the objects in the room, and we want to insert that heart. We're going to define an onCollide function for the heart, so this is only called when the player collides the way it's already set up. So in here, if the player collides, we want to increase the player's life by 1 heart, so each one is half a heart, so heal it by 2. Remove the heart from the game when the player collides with it, so that's just looping through all the objects. If the current object in the loop is a heart, which we define here, then remove it from the table, break out of it because we no longer need to do this for loop anymore, and just play a sound collect, which I've added in dependencies. So that's just a sound here. I've added actually quite a few of these: pot, smash, pick up, collect, and also various graphics, which I'll discuss soon. So that's the first requirement. Quite simple really. Again, in game objects, the frame is the current frame of the heart from the texture hearts, and that is defined here. 16 by 16 images which come from hearts.png, which is here, and frame number 5, 1, 2, 3, 4, 5. So we're just using that. Very simple stuff. Now the next requirement is add pots to the game world from the tile sheet. So the tile sheet, quite a big one here. I believe I'm using 16 here for the pots, so number 16 in this large sheet here. And add them to the game world at random so that the player can pick them up, at which point their animation will change to them carrying the pot. Okay, in the requirements it says that the player cannot collide with the pot. They should be a solid object. Now the first thing I noticed about this in entity defs, I believe it's game objects, here we go. We have this solid flag here, but it's not actually implemented anywhere in the code at all. So if we set this to true, the player, the enemies all walk right through it. So we kind of have to implement this ourselves, even though it's not in the requirements, in order for this to work. Because the requirements state that it should be a solid object and the player shouldn't pass through it. And another problem with that, if it is a solid object and the player can't pass through the part, then we can't use the onCollide because the player shouldn't collide with it. Well, it will initially, but it would be bounced back, so we'd have to set flags, and I thought that got a little bit complicated, so I'll show you how I implemented that. So one of the first things was implementing solid, because that wasn't sort of working from the get-go. So let's discuss everything I've added here. So in game objects, I've added a pot object, just like I did with a heart. It comes on the texture tiles, that's the big tile sheet. It's frame number 16, which I've just shown, 16 by 16, and it's a solid object. So that's that. Entity defs, let's go to the player, here we go. And type is player. Okay, so the type flag I added in game objects, I've also introduced this in entity defs, because I wanted enemies to go over the parts, but I don't want the, sorry, I want the player to bump the parts, but I want the enemies to go over them, you know, just hover over them. That was just a choice of mine. The problem is the enemies will then start bumping parts, and if you have a lot of enemies and a lot of parts, it gets a bit confusing and slow the way the AI works in the code. So I just allowed my enemies to go over the part and only have the player bump with it. So I added this type flag here to the player, and I just called it type equals player. I've left it off all the others because then it will just default to false. I just want this, so it will default to not player. So I've just added this so I can distinguish between a player and an enemy. So in entity.lua, so at the top, a couple of things I've added here. I've added has reward, which I've discussed, and also type. So this is whether this entity, it's almost like inheritance, like a base class. It's whether this entity is a player or an enemy, and it just passes that type in. So it'll be player if it's player, or nil or null if it's an enemy. So that's that. And I've also added carrying part. This is the third requirement where we're carrying a part. So I've associated a part with, which is an object, a game object, with an entity. So that means an enemy could carry a part. We haven't implemented that, but it could be a feature. But mainly a player will carry a part, and this will equal to a whole kind of pot object, not like a flag. So the whole object there. So they're the things I've added in entity. Then play state. Okay, so this is the current kind of play state. I've added in here. This is where I've added all my extra states to the state machine, which I will discuss shortly. But with the code, the dungeon, I believe, wasn't being passed into a lot of these states, and it was causing some problems when we went to implement some of our states. If you look inside the state, you can see it has a dungeon flag, but it wasn't actually being passed in. So I've dressed up a lot of this code just to always pass the dungeon into these states, because we need to look at what's in our dungeon to act on some of these states. So like when we lift the part, we need to know information about the part, and that is within the dungeon. But if we're not passing the dungeon in, then we're not going to know about this information. So it was mainly in some of these existing things I needed to sort of add that functionality into. So that's why this may look different, and I do believe it's needed. I don't know why that was left off. So in the play state, this is where our type comes in, whether it's a player or an enemy. So I've added that in, and also if it's carrying a part. So really we're just expanding on the constructor for the kind of play state class here. So they're the couple of things I've done here. And so I've discussed passing the dungeon in and the current room. I believe I also, oh no, this is correct. Yes, and I also passed the dungeon into here too, so the room knows about the dungeon. So it's I've kind of discussed it now. I believe, I hope you'll understand the reason behind that. So now in room.lua, this is quite a big project, so bear with me. So in the room, so I'll go to the top here. Okay, so in the room, when we generate the entities, so this is when we generate the enemies, the skeleton, the slime, it randomizes them and all stuff like this, gives them a health. I've also passed in the type here just for completion. And, this should be null or nil, but when we expand on this, we can use that logic. So that's whether we know if the entity is a player or an enemy, for example. So I've just kind of completed that constructor kind of call here. And again with the player as well, when we define the player, we're going to pass in a player. So that's just for completion. I've added a reference to the dungeon in the constructor. Yes, so I've added this. We're feeding in the dungeon into the room, so that every room has a reference to the dungeon that it that it comes from, or it's in. And in this is the main portion where we add pots to the level. You just bear with me while I find that. Okay, so let's add in the entities. Okay, so when we generate the objects in the room, so we're already adding the switch, so there's one per room. So just underneath that, we're generating objects. I'm adding 10 pots. What you can do here is just add something in constant, saying how many pots you want per level, or use a random, it's up to you. I'm adding 10 pots per level, it doesn't really matter. So this is pretty much the similar logic as above for generating a random switch, and for each one I'm generating, I want to insert them into the current collection of objects for the room. So that's all that does, very simple really. And I don't have an onCollide function for the pot because the pot should be solid, the player shouldn't pass through it. So if we collide with the pot, it's kind of weird that we might have to set flags if we use onCollide. So I didn't use onCollide, and I will discuss what I did do in a second. Entity walk state. Okay, so entity walk state is kind of like a base class for player walk state. So the player walk state discusses everything to do with the player. Then an entity is how players and enemies move. It's sort of like a base class. So in here for the update, I've introduced a few things. So I believe there was a local object called bumped. So when a player or an enemy bumped with the walls, so it's all this code here, it just sets bump to true. That's all it does in here, and then we handle that elsewhere. However, I want my enemies to go over the pots. I don't want them to bump with the pots, but I want the players and the enemies to bump with the wall. So I had to kind of separate that out into two variables. One called wall bumped, so that's whether an entity or a player hits a wall. And one called object bump, that's just when a player hits an object. I've set them both to false here. So this says if the dungeon is not equal to nil, for some reason when I run it, it's nil straight away, so I'll just check for that. We're passing the dungeon into the entity walk state. As I mentioned before, it wasn't there currently. Loop through all the objects in the room. Again, you could have a collection of pots, but I'm just putting my pots in with the other objects. If the type is pot, I've discussed, I added a type property in the game objects, and it collides with the entity. So this is the current entity, the walk state, it could be an enemy or a player. And then set object bump to true. So that's how we get sort of identify bumping between pots and the player. And when we handle that, that's how our player doesn't pass through the pot, but the enemies do. So in player walk state, here we go. Okay, perform a base collision. Okay, so if wall bumped, this was bumped before, but I had to change it to wall bumped. That's where we do all the logic for players and enemies kind of bumping the wall. And this is the large bit of code we added just for the player and object bumping. So this is our new kind of object bump. If our type is a player, because we added the type to the player, now we know it's a player, like the entity is a player. If we're moving left, so if we're facing left, I only want the player to bounce off pots and not enemies, so we loop through all the objects in the room. If it's a pot, and our entity, which is the player. So if our player collides with the pot, and it's a pot, and our entity is a player, okay, yeah, this is probably redundant now we have this up here, I can change that. Then bump the player backwards along the x-axis. So when we do +5, we're moving the character out of the range of the pot. You can adjust this, you can even put it in constants and say bounce back pixels or whatever you wish, and do that in every direction, so left, right, up, and else is down. That's the last way. Okay, so that's all I did with that, and that stops the player from passing through a pot. Now in dependencies, and again that we should utilize solid there and say if an entity is solid, sorry, not an entity, an object. If an object is solid, and also add that onto that if statement. So if it's solid, it's true, then do that logic. So that's a more complete way of doing it, but you sort of get the idea. So in dependencies, I've added more textures here. So I've got the pot lift and pot walk. They're the frames which map onto these textures here. So lift and walk. So pot lift. So these are the lifting ones. So that's facing down, facing right, up, left. So 1, 2, 3, 4, 5, 6. That's how the frames go. So that's lift. And pot walk. So with the walk, there's actually 4 across and 4 down rather than 3. So they're the sprites for those. We'll just add those into dependencies. So that's all we did with those. And I've also defined, I believe, 4 states, 4 new states. So player pot lift state, player pot walk state, player pot walk idle state, and player pot throw state. So 4 whole new states, 4 whole new files. So with adding new files, we have to reference them in dependencies. So while I'm here, I thought I'd just mention that. In entity defs, I've added all the frames and entity kind of definitions to handle that. So I've got the pot lift ones, which use frame 7, 8, 9 for up, the interval. I don't want to loop it because when you lift a pot, you don't want the player to keep lifting. It will look kind of silly. So we're not looping that behavior. For the pot walk, so when the player's walking north upwards, uses those frames. That's the texture it comes from. Very simple stuff. And player walk idle. Now this was a bit of a pain. I chose to implement it this way just because that's how idle is implemented. So when idle is implemented, it only uses 1 frame, which is the first frame in the collection of walking frames. Because when the character's idle, we don't want him to walk on the spot. It might look a bit silly. So when we're carrying a pot, we don't want him to kind of jog on the spot with a pot in his hands. So I've implemented pot walk idle. It uses the first frame of each in the pot walk collection. And pot throw. So pot throw, they're just the lift images, but in reverse. So when you lift a pot, it kind of looks like throwing a pot when you run it in reverse. So I've just literally reversed the frames, but used the pot lift logic here. And again, we don't want to loop throwing a pot because that would look a bit silly as well. So that's how I did that. Now let me start with pot lift state. Oh, and when you add states to the project, you need to go to play state and add them to the state machine, which is here. So I've got 4 new files, 4 new states. Add them all to the state machine, otherwise the state machine won't know about them. Pass dungeon into every one of them, and we're all hooked up with that. So let's have a look at pot lift state. Okay, so pot lift state. Okay, so this is a whole new class, whole new state that we can be in. So when we initialize the pot lift state, we want to change the animation to pot lift, then whichever way the player is facing. So it will be pot lift right, for example. And in here I've defined something called self.nearest pot, because when we lift a pot, we want to lift the nearest pot to the player. So that's where it gets complicated. As I say, we can't really use collide without setting flags and things like that. It get a bit messy. So what I did was just to find something called nearest pot, initialize it to 0. This is when we enter the lift state. This can be whatever sound you wish. It really doesn't matter. I left it for sword. I thought it actually sounded pretty good. So when we update on the pot lift state, we're playing the animation right here. And when that's all done, this is the bit of code I sort of decided upon developing. It works. Could it be more elegant? I don't know. Anyway, so I'll talk about this last. So I loop through every object in the room. If the object is of type pot, then I just want to say the nearest pot is just the first pot on the run of this loop. I could just set self.nearest pot is the first index in the list of pots, but then it could be null, so I need to check for that anyway, so I just did it like this. On the next run of the loop, we already have a value in our nearest pot. So what's happening here is we need to work out what the nearest pot is to the player. So what I did, I don't know what the best way is, but what I decided upon was the x and y axis of the pot. So the x-axis could have the same x-axis for the player, but the y-axis might be way off. Again, a different pot might have the same y-axis to the player, but the x-axis may be way off. So what I did, I added the coordinates of x and y for the player, and x and y of all the pots in the level. Math.absolute, that removes kind of like the sign off the number, so -3 becomes 3, 3 becomes 3, it doesn't change. And I've added up the y value for the player and the nearest pot, which we've currently stored, and the x-axis for the player and the nearest pot we've currently stored. And I've just set that to the player and nearest pot difference variable here, which I've defined. That will become important in a sec. And when we loop through each pot in the level, I just want to say, is the next pot closer, by adding up the x and y axis. And if it is, then the nearest pot is now this pot, because it's nearer than the one we've already stored. And just set the nearest pot difference to the logic we just had before for this object. So now at the end of all this, I have the nearest pot to the player. However, the nearest pot to the player might be 3 tiles away. We don't want to pick up a pot that's 3 tiles away. That'll look a bit silly. So that's where this variable comes into play here. I'm saying, okay, we have the nearest pot, but is the difference within 30 pixels of the player? 30 pixels works pretty well visually. Again, you can define this in constants and put an arbitrary value, whatever you want in there. So if it's also near to the player, we have the nearest pot, then set the player carrying pot, which I discussed earlier, to the nearest pot. Player pickup sound, which is like rip, which I've added in, and then change the state to pot walk. Right? If we have a nearest pot, but it's nowhere near the player, so it's more than 30 pixels away, then just revert to the idle state, which is the player standing there like a lemon. So let's assume this kind of logic flow exists. We're now moving on to the pot walk state, because we have a pot, we want to put the player in a pot walk state so it looks like he's carrying a pot. And that's all this right here. So player walk state, we initialize the player walk state. It knows about the player in the dungeon. It's just some offsets. This allows us to kind of sit the pot on the player nicely. I'll discuss that. So in the player walk state, we can move left, down, right, and up, because we want to kind of copy that walk behavior. So even though we're carrying a pot, we should still be able to walk, and we should still be able to be idle, etc. So that's kind of handled that there. Sorry, I'm in player walk state. Player pot walk state. That looks a bit better. So in the player pot walk state, we're changing the animation to pot walk, and then left, right, down, up, whichever way the player's facing. They're the offsets. We can still walk. I've discussed this already, but this is why the other file looked a bit weird, because it should be the idle state but for pot walk. So if we're not moving, so we're holding up with a pot in our hands and then we let go of up, we don't want to let go of the pot, because we want to let go of the pot when we press enter again. So we want an idle state where the player is just standing there with a pot in his hands, depending upon the direction the player is facing. So if we've let go of all the keys, up, down, left, right, we want to put it in a pot idle state. And then we just change the state from the walk state to the idle state. So pot walk idle state right here. So in the idle state, again, similar stuff as before. So if we press left, right, up or down in the idle state, just go to pot walk state. The thing about the idle state is that that's when we can also handle the pot throwing. We can throw the pot in the pot walk state, and we can also throw a pot in the pot idle state. So there's two places where this can happen, and I'll discuss that in a second. So carrying on with this. Okay, so this is in the update for the pot walk state. We want our pot that the player is carrying right here. This is the player entity. He's carrying the pot because we discussed that earlier. We set it to the nearest pot. And the X and Y axis of the pot is equal to the player, except the Y axis, because we want the pot to appear above the player's head. So nudge it by 8 pixels. And again, just like the idle state, we want to be able to throw the pot in a pot walk state as well. If you don't have it in the idle state, then you can only throw a pot while walking, and it's a bit weird. So put this in the pot walk idle state and also the pot walk state, and that enables us to change our state to pot throw, which is a new state that we've added, and I will discuss that in the third requirement, because that's when we talk about throwing. And I believe that is all the states I've added. We've talked about adding them to the state machine. Okay, entity idle state. So this is kind of like a base class for the idling of the player, and this bit's quite important. We need to change our idle animation depending upon whether the player is carrying a pot or not. So when we come into this kind of base idle state class, we're saying, is the player is self.entity, is this carrying pot property nil? Well, if it is, then he goes in an idle state because we know he's not carrying a pot. If it's not nil, then the player has a pot associated with it, and there's a pot above the player's head, so we want to change our animation to reflect this, and this will be the pot walk idle. So he has a pot and he's idling, but he's in a pot walk state. So this bit's quite important there. I believe that's everything in the idle state, and also the player idle state. Go in here. Okay, so the player idle state, yes, this is where we handle the lifting of the pot. So if we press enter or return right here, we want to change the state to a pot lift. So that's how it all hooks up into the game. So just like we can press space to swing the sword, we want to press enter to lift the pot. That changes it to the pot lift state, and that's where all our logic comes into play and hooks up with the game. So these states, the pot lift, pot walk, and pot throw, all kind of tie into each other, and they're called from each other, kind of like as a sequence of almost like events that might happen with an intermediate pot idle state, which is where you put the player into idle. And that's how we pick up a pot and walk with it. So the last requirement is actually throwing the pot. And this is where we introduce a projectile and a pot throw state. So I discussed when you're in a pot walk state, you can, or in pot walk idle state, you can throw the pot by pressing enter again. So if I go to the pot throw state here, so we define the state. When we enter the state, I did the sword sound because I'm lazy. Okay, so when we update the state for pot throwing, let the animation play once. Good testing there. Throw the pot. Okay, so what I'm doing here is, I think I'll talk about the projectile first and then loop back to this. Okay, projectile. So this is a new class I've created called Projectile. Add it to Dependencies so we can link in. So projectile The first thing is the projectile itself, so this will be the pot. With our game right now, it'll always be the pot, but we call it a projectile because we could be throwing enemies. We might want to evolve this onto anything, so we call it a projectile. So this will be the pot. Pixels to project, so that's the number of pixels we want the projectile to travel. So I think in the requirement it was 4 tiles, so we just do the tile size times 4 when we call this constructor. And also the direction, and that will be the direction the player's facing, so that could be up, down, left, right. So what we do here, we store the initial coordinates of the projectile, so that's the start point. So the start point of the projectile will be the current pot location, X and Y. I've defined a property here called complete. That's set to true when our projectile has completed its mission of going along this many pixels. And we just set it to true. So in the update for the projectile, this is where we move it. If the player's facing left, that's the direction being passed in. We want to change the x-axis negatively because it's left. Pot throw speed, so that's something I defined in constants, so that will be the speed of the pot. It's just a variable I've defined in constant, so that's how fast the pot will move. It can be ridiculous, it's up to you. Times delta time. And if the initial coordinate of the projectile, which is the pot's location in above the player's head, take away the projectile x, so that's the currently incrementing projectile, which is always moving. If it's more than our pixels to project, so that could be 4 tiles, then we know the projectile's done. It's met its target, set it to complete, all done, don't need to worry about it anymore. So that's how the projectile works. It's based on 4 directions. We just literally change the axis, the x or y axis of the projectile. Very simple. Now how we hook that up is, I was just talking about it a second ago, in player pot throw state. So we say if the projectile, I store a projectile here, so when we throw a pot, the projectile in this class anyway will always be a pot, so we can call this pot, it doesn't matter. If it's nil and we don't currently have a projectile, don't worry about it. If we do, then we're saying the pot has something called projecting. I talked about it earlier. So the pot is a game object called projecting, and this will be whether the object is currently being projected. So we can project hearts, we can project any object, we can project switches, hearts and pots. The way this is set up anyway. So if it's projecting, which is true, this gets set to true right here. If the player's facing up, then we want to create a new projectile, call that constructor. We give it the pot which the player is carrying. I called it carrying pot. It should really be something like player's pot that he might be carrying. I don't know, it really doesn't matter, readability. This is the distance that we're going to project the pot, so tile size times 4. I think they're 16 pixels each, so 64 pixels, I believe that's right, and then pass it in the player's direction. So the reason I have all this, because I changed the code a few times, so we don't really need to do up, down, left, right anymore. So good old testing, so that can just be that, because we're letting the projectile handle the direction rather than the player pot throw state handling the direction. We don't need to handle it twice, so that can just be minimized just like that. So that's how it works. We call the update method on the projectile because when we're in the player pot throw state, we're updating. We want to make sure this projectile is updating too, so it calls that method in the projectile, and that's where it actually moves the projectile. And once the animation changes, revert to pot carry if there's a pot nearby, so ignore that. If the projectile is complete, so that's in our projectile, you know, it's complete when we know it's past the desired amount of pixels, then no longer set the object to projecting anymore. We want to set it to false, so we're no longer being projected, you know, that part is no longer flying through the air, so set it to false. The player is no longer carrying a part, so set that to nil, and then change the player's state to idle, so that will so this is the current state the player's in, the player pot throw state. So the player is going to be kind of praying because it will be the lift state in reverse. We want to make sure the player is just standing idle, you know, standing there like a lemon. So we do all this when the projectile has, you know, reached its target. So a little bit confusing to explain, but it makes sense. So in game object, yes, we discussed that. Okay, now room.lua, this is where it all ties together. So I believe in the update function. Okay, let's talk about that in a second. Okay, so this is our main update loop for the room. So we're looping through every entity in here, just like I talked about with the hearts. This is where we have a collision between the pots and the enemies. So if the entity is not dead, so, you know, an enemy, if it's alive. Oh, one thing I did notice was when enemies are dead, they're not actually removed from the level. When you expand on the game, they should really be removed. But the way it works now, when we go in a new room, we get new enemies and it's all redone, so it doesn't really matter. But when an enemy's dead, it should really be removed from the table. The code's not doing that. It never did. Don't know why, but there you go. It's just having a dead flag. That's all that's happening. So if the enemy is not dead, loop through all the objects. If the objects are part, and the enemy, which is the entity here, so that we're looping through all the entities in the level. And the object is projecting, so we know from before when our pot is moving, we set our projecting flag to true when it starts its journey and false when it stops. Then deal 1 damage to the entity, which is the enemy. Play a pot smash sound, I wasn't too lazy to add that, and then remove the pot from the game. Again, you could play an animation here like pot explodes, it's really up to you. I just removed it, it was easier. And that has the effect of damaging the enemy. The enemy will die in the internal logic in here, so we don't need to worry about that. All we need to do is deal the damage and remove the pot from the game. Okay, so that's how we sort of implement pots colliding with enemies. And now the last part is collision between a pot and a wall, which is slightly different. We don't want to put that logic when we loop through entities because it's going to be called for every entity in the level. Instead, we want to put it up here out of that loop. So what we're doing, looping through every object, just like we did down there. If it's a pot and it's projecting, already talked about that. Set a local variable called pot smash to false. If the object x, so this is the pot, if the x-axis of pot is less than the offset map plus the tile size, so this will be the left hand wall, set the pot smash to true. So that's checking the left edge, the left wall. Again with left, right, up, down. Bottom edge slightly different. This code is similar to when entities, or which could be an enemy or a player, interacts with a wall. They sort of bounce off it or just freeze. So that is similar logic there, but we're doing it with a pot smash. So if pot smash is true, by checking all the walls, play a pot smash sound, and again remove the pot from the game using similar logic to when the pot hits an enemy. And I believe that is everything on how we implemented pots, hearts, collecting hearts, increasing the life bar, making pots go away, carrying pots, walking with pots, picking up pots and throwing pots. So it was a big one this time. But yeah, it was really fun actually, and the game, the way it's laid out now with the state machines and the events, is really expandable, so you can create a pretty good game out of this. So I hoped it helped. Sorry it was a bit confusing, a little disorganized, but it's really hard to know all the changes are made and keep track of them and present them and show you them and explain them. So I hope that's good. Enjoy it, and yeah, I hope you enjoy the game. It's pretty cool.